Well, we've got an integral to try here. The integral, we're looking for all antiderivatives, all functions who have derivative x times the square root of x plus 4. Normally I begin looking for algebraic ways of manipulating this to simplify the integrand. In this case I don't see any, so I will try a substitution. We could rewrite this once as x times x plus 4 to the 1/2 exponent. That doesn't provide us with any new algebra approaches, but it does give us a simpler form for the integral after we complete our substitution. So I'll let u equal x plus 4. Again, the substitution, you select the inside on the chain rule that was used to generate this derivative, and the only bad choice for u typically is letting u equal x. And the rule of thumb I'm using here is the inside is the portion I'm after. So if I let u equal x plus 4, du then is a calculation. Derivative of u, which in this case is 1, times dx. It's just simply 1 dx. Now we rewrite the integral. A portion of this, of course, is easy. The x plus 4 to the 1/2 is a u to the 1/2. The dx and the x need to be covered now, need to be replaced in the new integral in terms of the variable u. Du is exactly equal to dx, so I can put that in fairly easily, but it's this lonely x that needs to be taken care of. This is what I refer to as a type 3 integral substitution. We're going to need to return to this line right here and solve for x. According to this line, x is equal to u minus 4. So we'll replace in the integral what was an x with a u minus 4. I'll now use some algebra to simplify this integral. The integral is rebuilt. Everything in here now is equivalent to portions in the original integral, but this form does not directly present the antiderivative to me. So I will distribute this u to the minus 1, or u to the positive 1/2 through this difference. So I'll get a u to the 3/2 when I take u times u to the 1/2, and minus 4u to the 1/2 when we multiply by the 4 and attach the minus sign. These antiderivatives are fairly straightforward now. Increase the exponent by 1, multiply by 1 over the new exponent, and on this one I'll pull the 4 out of the way, increase the exponent by 1, 1 more than 1/2 is 3/2, and multiply by 1 over that new exponent, which is 2/3, and then we'll add our constant on. To finish this problem out now, I'll simplify this last form and return it to the original variable x. Again, we said u was x plus 4, so this is 2/5 x plus 4 to the 5/2 minus 8/3 x plus 4 to the 3/2 and plus c. And now to check my work, I will differentiate the answer and see that I get the integrand back. So the derivative of x plus 4 to the 5/2 with the 2/5 out front minus 8/3 x plus 4 to the 3/2, and in each portion here I will need to use a chain rule. Bring the 5/2 down, pulling the 2/5 out of the way, reduce the exponent by 1, 1 less than 5/2 is 3/2, multiply by the derivative of the inside, which is 1, bring the exponent down, leave what's inside alone, reduce the exponent by 1, it'll be a 1/2, multiply by the derivative of the inside, and the derivative of our constant is 0. Now if I clean this up, the 2's cancel, the 5's cancel, so I get an x plus 4 to the 3/2 minus, let's see, the 3's cancel, 2 goes into the